Empirical rule. Empirical rule applies to any normal distribution. It states that 68% of data lies within one standard deviation of the mean, 95% of data lies within two standard deviations of the mean, 99.7% data lies within three standard deviations of the mean. So what we are saying is described in this picture. So if you, from the mean, if you add one standard deviation and subtract one standard deviation, then within that one standard deviation from the mean, you have 68%. And then similarly, if you go two standard deviations here and negative two standard deviations, then that total area is 95%. So we're talking about the area inside the curve. And within three standard deviations, the area is 99.7%. And this is an approximation, but a very good approximation, and therefore we will use empirical rule whenever they tell us to use empirical rule, and also sometimes we can use it in real life to estimate things. So let's consider the following problem. According to empirical rule, 68% of area under the normal curve is between mean minus a standard deviation and mean plus a standard deviation. So here they're using S for standard deviation, but you can also use sigma if it's population. What percentage of area is between nu and nu plus sigma? So between nu minus sigma and nu plus sigma, it is from this point to this point, and that is 68%. So we can look at another picture which describes these areas in a more colorful way. So we have 68% if you go one standard deviation here and negative one standard deviation. So the total area is 68%, and remember, mean is always in the middle of a normal distribution. So this is mean minus sigma, and this is mean plus sigma, and that is 68% area total. And they are asking how much is there between mean, which is the center, and mean plus sigma. So that is just half of 68, and so that's why we've divided into 34 and 34. And so if you just go halfway instead of the full way, then the area would be 68% divided by 2, that's 34%. And then they ask what percentage of area is more than one standard deviation. So more than one standard deviation is the opposite of within one standard deviation. So within one standard deviation, we have 68%. The total area is 100%. So the more than one standard deviation would be 100% minus 68%. So that is 32%. And from this picture, 68% is this area within one standard deviation. So more than one standard deviation would be either on this tail or on this tail. And that would be the remainder that is left over after 100, subtracting from 100. So 100 minus 68 is 32%. That's the area which is more than one standard deviation from the mean. Problem. Suppose heights of baby girls of a certain age have normal distribution, mean 25 inches, standard deviation 2 inches. Suppose 2,000 girls are sampled. Use empirical rule to find A, the percentage of girls between 19 and 31 inches. So first we have to decide how many standard deviations we are talking about so that we can talk about the empirical rule. So we will change the 19 and the 31 into z-scores, and that gives us how many standard deviations. So z is obtained by x minus the mean divided by standard deviation, where x is the value whose z-score we want. So in this case, the values of interest are 19 and 31. So we will find z of 19, which would be 19 minus the mean. Mean was 25, standard deviation was 2. And that gives us negative 3. And the other one was 31. So 31, z of 31 will be 31 minus 25 over 2. And that gives us standard deviation of 3. So we are talking about 3 standard deviations from the mean, and we know that the area within 3 standard deviations is 99.7. So whenever they say find the area between this and this, and you find equal number of standard deviations on either side, one positive and one negative, then it's just a straight up looking up what the empirical rule is saying. So if it's 3 standard deviations, we are talking 99.7% area. And then they say, what's the number of girls whose height is between 19 and 31 inches? So the percentage was 99.7, and the number of girls would be 99.7% times the total girls. So we are saying 99.7% of the girls have height between 19 and 31 inches. So the number would be 99.7 times the total number of girls, which was given to be 2,000 in the problem. So 0.997 times 2,000, that's 1994. Part C, the percentage of girls whose height is less than 21 inches or greater than 29 inches. So we will change the 21 and the 29 into z-score. So z of 21 would be 21 minus the mean over standard deviation. That's -2. Z of 29 would be 29 minus the mean over standard deviation. That's 2. And so this time we're talking about 2 standard deviations. So now they are not asking between 21 and 29. If they were, then since it's 2 standard deviations, then that would be 95% by empirical rule. But they're asking again less than 21 or greater than 29. So see, the 2 standard deviation mark is this one here and this one here. And if they were asking between the two, then we know it's 95%. But they're asking either less than that or greater than that. So again, it's the leftover area after the 95%. The total area is 100%. So this one will be 100 minus 95. That is 5%. And then in D, they ask the percentage of girls who are more than 29 inches. So between 20, in the previous part, we found the ones who are less than 21 or more than 29 inches. And so less than 21 was on this side and more than 29 was on this side. And that total came out to be 5%. Now they're asking just the less than 21, and that means they're just asking half of that. Remember, normal curve is completely symmetric. So if the two tails together have 5%, then half of the tail will have 5% divided by 2. That's 2.5%. Part F is saying percentage of girls between 27 and 29. Now the difference between this part E is saying percentage between 27 and 29. Now the difference between this part and the remaining parts is that in the remaining parts, we got negative and positive, the same number for the standard deviation. So we were in a symmetric situation because one number used to be below the mean. Remember, mean was 25. And in all these previous parts, one number used to be below the mean, one number used to be above the mean. And it was no issue. It was quite a straightforward application of empirical rule. In this case, if you notice, both 27 and 29 are above the mean. So therefore, that colored graph that we saw earlier will be very helpful here. So we were talking about between 27 and 29, so we will change them into z-scores. So z of 27 is 27 minus the mean over standard deviation, that's 1. Z of 29 would be 29 minus the standard deviation, minus the mean over standard deviation, that's 2. So actually we're talking between 1 standard deviation and 2 standard deviations. So remember, this is the 1 standard deviation mark, this is 2, this is 3. And we can easily see how so between 1 and 2, it's the 13.5%. So if you just memorize this graph, you know the answer right away that it's 13.5%. But let's say all you memorize is those 3 numbers, which actually is sufficient, the 68, 95, and 99.7. So remember, 1 standard deviation is 68%. So we split it up into 34 and 34 like that. And now 2 standard deviations, the area within 2 standard deviations is the area from this mark up to this mark. We know it's 95%. So this one is 68. So And from here to here, it's 95. So if we subtract the two, we get this and this. So if we do 95 minus 68, let's do it here. If we do 95 minus 68, that actually gives us 27. So that means that the area, this green area plus this green area is 27 because this together with the 68 has to add to 95 total. So if this one plus this one, this green plus this green is 27, then each of the halves will be 27 divided by 2. And 27 divided by 2 is 13.5. And that's how we got 13.5% here and 13.5% here. And then let's look at another problem. The problem is that weekly study times for college students are normal with mean 20 hours, standard deviation 3. Give an interval around the mean when 95% of the study times fall. So we know that 95% corresponds to 2 standard deviation by empirical rule. Uh, since 1 standard deviation equals 3, so 2 standard deviations will be 2 times 3, that is 6. And to get an interval around the mean, you will basically subtract these 2 standard deviations to get the lower bound, and you'll add these 2 standard deviations to get the upper bound. So the mean was 20. So when we subtract the 6 from 20, we get 14. And we add it, we get 26. So the required interval is 14 through 26. And then remember that a value which is 3 or more standard deviations away from the mean is considered unusual in this course.